Now we will be discussing what, children? We will be discussing alloys. Once we are done with the extraction of aluminium, this is the next part, that is alloys. Now you have been studying this from the previous classes, children, that what are alloys? Alloy is a substance that is prepared by adding metals or non-metals. Okay, so basically when we are adding two metals or maybe a metal or a non-metal, so we are getting an alloy. And there are reasons why make an alloy. So what is happening, that it is usually okay, then why do we need to make alloy, children? That is an important thing. So there are certain things, what happens, there are certain properties which we desire, which we are not able to get from certain elements. Okay, so what happens, certain metals which are there, when we combine them, they become more stable, and then I am able to use those property. So if you see here, alloy is a substance prepared by adding metals to the base metal in appropriate proportion to obtain certain desirable properties. So the reason why I am making alloy is that I need certain desirable properties which are there, children. Okay, for example, I want to increase the conductivity, or I want to make it more ductile or malleable. So these are the desirable properties. So what are the properties which I require? Based on that, I'll be changing the composition of the particular mixture. Alright, now we'll move to what, children? Now if you see, the second point which is there is, its components must be miscible in liquid state and not separated on solidification. Now what happens, children, when we are making an alloy? So basically when we say that this is an alloy of aluminium, suppose, or if we say that it is an alloy of iron, that is Fe. So what happens, children, when we talk like this, this means what? Aluminium is my base metal here, and to it I'll be adding other metals. So base metal means what? That will be the metal that will be present at the large quantity. So in an alloy, if we say it's an alloy of iron, it means that it contains iron in a large quantity. So this is the way it is. So what is happening? It is usually made by, how do we make that? We just melt the components together and solidifying the mixture. Suppose I want to make an alloy of Al and Fe. Suppose what I'll do, I'll just melt Al, I'll melt Fe, then together I'll bring them in molten state. Okay, so once it is in molten state, once they are they just come below their melting point, after reaching their melting point they become molten, and then we go for solidification. Okay, so this is the way an alloy is prepared, molten state, and from molten state we will go for solidification. So this is the way it's being prepared. Now what is that there, children? It should be mixed in liquid. Miscible in liquid means what, children? It should be easily mixed in liquids in such a way that they are not at all separable. Okay, and then what happens, it should not separate on solidification. Okay, suppose I'll give you an example here. Suppose I am making an alloy of Al and Fe. Okay, so whenever I am making an alloy of Al and Fe, okay, I am just going for this molten state, and molten state is again going for solidification. Now when you are going for this solidification, children, what is important for you to notice is that there should be such a complete mixture. It should not be like that I should be able to see aluminium here separately, here Fe separately. No, the entire mixture should be as such that it is unrecognizable. We cannot make out the individual components which are there on solidification. Of course in molten form they might be separatable, but they should not be separatable once they are solidified. Now the third thing is what, that, children, see, its properties are intermediate between those of the metal composing them. So what will be the properties of this alloy, children? From Al, whatever properties I am having, that property it will be having. From iron, whatever properties which are having, it's not necessary that all the properties will be there, but the properties which will be there will be some way varying between the constituent metals which are there. Now what is an amalgam, children? This is an important one. This is an alloy in which the base metal is mercury. So whenever we are saying that it is a zinc amalgam or any other type of amalgam, whenever you are getting a word amalgam, it particularly means what? That it is a alloy which is having the base metal as mercury. Okay, so we'll write this down, that amalgam is an alloy with base Hg. Okay, so this is the thing. Now we'll be moving to different types of alloys which are there, children, if you see in the book. So here we have alloy of copper and zinc. Okay, so what is happening? The first alloy is what we are having, children. If you can just see here, I'll just magnify this. The first one is called brass. So brass is basically what it is. If you see, the copper is present in the greater concentration. So the base metal which is there is copper, and then we have zinc. So what is there, children? You will have to remember. So for 1 mark it can be asked, what are the constituents of brass? Then we have bronze. Bronze has got even more amount of copper. Then we have zinc, and then we have Sn as well. Okay, so this is the thing. Now third we will be moving to what? German silver, which is again an alloy of copper and zinc, and of course we have nickel also. Okay, so when we talk about German silver, this is an important one, children. So you have to remember the constituents. It consists of Cu plus Zn, and then it also has nickel. Okay, so this is the thing. Then when I talk about gunmetal, then the constituent has been given, and the bell metal. So if you want to know that what all things are important in this, children, you can just remember the first three the alloys which are there. They are very important: brass, bronze, and German silver. Then when I move to why do we go for making bronze, children, what is the property and what is the use I am getting out of making that alloy? So the property which is there, children, it is very hard, it is lustrous. So if it is hard, children, of course it will be more durable. Okay, and then it is easily cast, malleable, and ductile. So individually what is happening, of course zinc and copper being metals, they must be malleable and ductile, but when I am making it still in the form of alloy, it is still becoming more hard, lustrous, malleable, and ductile. And where do we use it? We use it in electrical fittings and decorative articles. Similarly, bronze has got certain properties, children, that it is hard, brittle, takes up polish. Then again we have other metals which are there, other alloys which are there, and their properties. So just go through the table which is there in your textbook, and it's there here as well, so you can just have a look. So the basic thing is that, children, that what is the reason that I am making an alloy? Just I want to improve the properties of that particular metal which is there. What happens, there are certain properties which I cannot get from only single metal, so that is why I'll be making it in the form of alloy. So here we saw what? Copper and zinc alloys. Now second we will be moving to aluminium alloys, children. Okay, so aluminium alloys means are what? Duralium and magnesium. So this you have to remember. So duralium will be having, both of them will be having 95% of aluminium. Okay, so this is my duralium and magnesium. Okay, and then you have to remember that what are the difference between them, children. Here in magnesium I have only Al and Mg. Okay, the concentration of the rest 5% concentration is of magnesium, and here I have Al, I have Mg, I have manganese as well, and then I have copper. So this is why the composition of both is different and hence different name. Then where do we use duralumin, children? Okay, duralumin is used, it's not duralium, children, it's duralumin. Okay, that is being used in aircrafts. Okay, you must have heard that the body of aircraft is made up of aluminium. So we are not using that aluminium direct, we are just converting it into duralumin and using it. When I talk about magnesium, it is very light, hard, and that is also used in making aircraft and scientific tools which are there. Next we will be looking into what, children? Next we will be moving into the lead alloys. Okay, what are the alloys of lead? So if you see, this is very important, children. The first one, that is solder. So that you have to remember. Type metal is also important, but solder is more important. So what are the constituents of solder? Here we have lead in 50% and then we have tin 50%. So both of them. Okay, so this is what you have to remember, children. This is very important. So how can you remember? First letter is solder is S, so we will be having Sn, and then I'll be having Pb. Okay, so this is my, and what are the uses? It is used in electrical fuse. Yes, this is very important, children. What happens now, whatever the fuse you are having in your appliances, okay, if you know, then all those are made up of what? Solder, because what is happening, that the melting point, it just lowers the melting point of alloys. So if the melting point is lower, what happens whenever there is an electricity rise? First, what will happen? The fuse will melt, and if it is melting, then it will break the circuit, so we can just protect our appliances from the short circuit. So that is the help of, that is the use of solder. So you will be remembering what, children? That the very important lead alloy is solder. Okay, and then we'll be moving to iron alloys. So we all know, this is very important, is my stainless steel. So stainless steel is very important, children, and you will be studying its constituent as well. The main constituent, of course, is iron. Then I'll be having nickel here. To this I'll be adding chromium and then carbon. Similarly, I have second, that is called nickel steel. Okay, so if it is having nickel, as the word says, but the base metal is always Fe. Okay, in nickel steel, the base metal is not nickel, and then as the name suggests, we will be having nickel in this, and of course we have carbon as well, Ni plus C. Okay, so this is the thing. And what is the stainless steel, children? We know that we all have heard that stainless steel cutlery we are having, the utensils normal, and then nickel steel is being used in aircraft part and tables which are there. So we are done with the chapter, children. What all things we have studied, we'll just discuss in the summary part, and then we are good to go. So in the introduction, what we studied was metal. So what was in metal? It is an element which ionizes by losing electron. Okay, metal is the one which loses electron, and non-metal is the one which gains electron. Okay, so this is what we have studied. Now how do they occur? So this is also what we have studied in the occurrence form. What are the common ores of aluminium, children? Bauxite, cryolite, corundum, and then zinc, we have zinc blende, calamine, zincite, and ores of iron are hematite, magnetite, and spathic iron ore. Alright, so these are the things which are there. Now we'll move to the next part, which is there in the summary. What did we study? We studied what the extraction of metals. So if you remember, in the extraction we had 4 processes. The first process, if we remember, is called my dressing. Okay, in which what we did, we just removed the external impurities or the gangue particles or the matrix which were there. And if you remember, what are gangue particles, children? These are the impurities which are in the form of the earthen impurities which are there, like my mud or SiO2, that is silica, or the small stones. These are called gangue particles. Now that in the first step we just removed them. Okay, so what happened in the next process? So whatever concentrated ore I got, I just converted that into its oxide form. Why did I convert into oxide form? Because reducing oxide is an easy one. Then what we did, children, when from oxide I just converted it into metal. Okay, this was third step, and then this metal was further purified. This was my fourth step. Okay, so these were the steps of purification of extraction of metals from the ore which was there. And then we discussed about extraction of aluminium. What were the steps? The first step was what? Wherein we saw Bayer's process, where what we did, children, this impure alumina which was there, we just reacted it with what? We reacted it with NaOH, and what did we get? We got NaAlO2. okay, sodium aluminate, that was further hydrolyzed to give NaOH, precipitated form of AlOH thrice, and this AlOH thrice was further heated up to 1100 degrees Celsius to give me molten alumina. Now the second Al2O3 is my alumina. The second step which was there is the concentrated ore was getting converted into its oxide form. Now since it is already in oxide form, we just skip the second step. Now what happened in the third step, children? Here we used Hall-Heroult process. So there was an electrolysis process which was there, in which what was there in the, if you remember, there were three things. We had cryolite, we had fluorspar, and then of course we had alumina as electrolyte, and then we were having cathode in the form of carbon linings of the cell, and the electrodes of carbon were acting as anode, and that was the way. So the further reactions which were there are discussed here, that we have discussed already, and the step 4 was called Hoops process, in which we did electro refining. So there were some 4 ingredients which acted as electrolyte, children, and in the cathode we had pure aluminium, and in anode we have impure aluminium. So this is the way we did this. Now we will be moving to what, children? We will be moving to the next part which we studied. We studied about the alloys, we studied about carbon and zinc alloys, we studied about aluminium alloys which were there, we studied about lead alloys and Fe alloys. So you have to study what, children? See, already we have some good 10 numbers of alloys, 10 to 12 numbers. So what you can do, you just study the constituents. It's okay if you don't study the percentage composition, but at least the composition part you have to study, so that in exam whenever it is asked, it can be written properly. And what is their properties is more or less, if you want, if you study, this is well and good, or most of the time only composition is being asked, so you should study that, and then you can go for uses. Okay, so basically uses is for, so if you see for aluminium alloys, you can remember easily they are being used only for aircraft. Okay, and then beam balance of course, and then one more thing is being used in aircraft, that is my nickel steel. You all already know what is stainless steel, so that also you can remember so easily. And then we discussed about solder, that is used in electrical fuse. So this way the use part you can remember easily and just learn this table. Then what are the other things which are there, children? In the other part I am having this, the properties of metal. These are being given only for reference, they have written. Okay, so what is happening when the aluminium is reacting with air? Okay, when it is reacting with steam, when it is reacting with chlorine, when sulfur, these are the reactions which are there. Okay, so these are for references only. This is what they are saying, children. You can just have a look into them. You can just go through the end products that they are forming. That Al is forming Al2O3. Okay, whenever a metal that is reacting with oxygen, that is only your air, it forms oxide form. If it is reacting with steam, steam is what your ultimately it's water. So that will be forming what? There it is forming again Al2O3, means the oxide form. When it is reacting with chlorine, it will be forming the respective chloride or the halide which is there. For sulfur, it will be forming the sulfide, and then these are the ways. Okay, so you'll be having just to look into this. And then the uses part which are there, children. What are the uses of aluminium? Of course, in this part what you can write, if you have studied the uses of the alloys, then you are good to go. So aluminium, here also you can see that it can be used as what? It is a very good conductor of heat, it is cheap, and then we have foils. Okay, and then it is used in paints, okay, as an anti-corrosion. So these are there. Zinc is the use in galvanization. Okay, pig iron which is there is used in pipes and gutter covers, and then we have steel. Okay, steel is having a very high structural strength, children, and that is why it is being done in that part. So this is the way the thing has been done. So the chapter has been done, children. Now what? You will just go through the chapter, and what are doubts which are there, we can simply ask. Just learn the composition and properties and different processes which are there nicely, and then you are good to go. Alright, thank you, students.